Solve the following system of equations for all three variables. So in this situation, we can see that neither my x's, y's, or z's are all aligned with opposite coefficients of the same number to eliminate. So the one that looks like it might be the easiest variable to manipulate is z. So if we see here, the first equation has a negative 4z, and the last one has a negative 4z. So if in our second equation, we can turn the 2x into a positive 4z, this should eliminate z's for us. So I'm going to take my initial 2x plus 5y plus 2z is equal to 2. And I'm going to multiply the entire equation by 2. And this will give me a 4x now. I mean a 4z and a 4x. So we'll have 4x plus 10y plus 4z is equal to 4. And now I should be able to manipulate. So we want to align our different z values. So if we see here, we'll set up our first equation, 4x plus 9y minus 4z is equal to 6. And because we have a negative 4z, we're going to want to set it up with a positive 4z. So we'll take that second equation that we manipulated just now to be able to align it. And then we're going to do the same thing now with the second and third equation, because the second equation has the positive 4z and the third equation has the negative 4z. So 4x plus 10y plus 4z is equal to 4. And we'll set it up with 5x plus 10y minus 4z is equal to 10. And now we're going to go through and eliminate our z variables. So the 4z and negative 4z cancel out. This is going to leave us with 8x plus 19y is equal to 10. And then we'll see on this side that the 4z's are going to cancel out, and it's going to leave us with 9x plus 20y is equal to 14. All right, and now we're going to need to do some manipulation of these two equations here. So if I set them up next to each other, we're going to have 8x plus 19y is equal to 10, and then 9x plus 20y is equal to 14. And in both of these situations, we're going to need to create opposite coefficients. So if we see here, I think it would be easiest to deal with our x's. So we're going to want our leading coefficient for our x's to be 8 times 9, which is going to give me 72. So let's take our first equation and multiply it by negative 9. That way our first equation has a negative x value. And let's take our second equation and multiply the whole thing by 8. And when I go through and do this, I'm going to be left with negative 72x. 19 times negative 9 is going to be negative 171y is equal to negative 90. And then we're going to have 72x, 8 times 20 is going to be positive 160y is equal to 112. All right, and we'll see here that we can start canceling things out just like we saw earlier. So we're going to eliminate our x values now. And then this is going to leave us with negative 11y is equal to 22. And then we can divide by negative 11 on both sides. And this is going to leave us with y is equal to negative 2. So now that we have y, the next variable that makes the most sense to solve for is x, because in this step of the equation here, I'm trying to decide what color to use. Okay, in this step of the equation here, we had both equations with just an x and y value. So we can do 9x plus 20 times negative 2 is equal to 14. So 9x minus 40 is equal to 14. We'll add 40 to both sides, and we'll be left with 9x is equal to 54. And when we divide by 9 on both sides, we're left with x is equal to 6. And now the last step of our equation is we have x, we have y, we need to get z. So we can use any of the original equations to solve for z. So in this situation, I'm going to suggest we just go with the first one. So we have 4 times x, which is 6, plus 9 times y, which is -2, minus 4z is equal to 6. So we get 24 minus 18 minus 4z is equal to 6. 24 minus 18 is 6, so 6 minus 4z is equal to 6. We're going to subtract 6 from both sides, so -4z is equal to 0. And when we divide by -4 on both sides, we're left with z is equal to 0. So my final answer is going to be the coordinates 6, -2, 0.